computational fluency in second grade is grounded on place value. So we want kids to be able to understand what the digits in each number mean and what is their value. So we start off with very concrete manipulatives. You've probably seen the little blocks. These little cubes represent 1. And we show the students that when they get 10 of those, that represents a 10. We call this a 10 rod. When they get 10 of these, that represents a flat, which represents the number 100. So we do a lot of work with these. Then we teach the students to be able to draw these. And so when we draw these out, we want them to be proportional in size. So this one would represent 100. When they draw 10 rods, we want them to be tall as the 100 and really narrow. So this would represent 10, 20. This represents 30. And then we also show students how to make the small cubes that represent 1. So we have 1, 2, 3, 4 here, so that's 4. And then we can take this, and students can actually see that this number is 134. And from that, we can ask them to be able to write it in expanded notation, which would be 100 plus 30 plus 4 equals 134. Once students understand place value, we can start to show them how to add numbers together. We try to get away from the picture drawing because we want them now, in about mid-fall in second grade, to be able to decompose a number, and sometimes we call that putting it in place value. So the strategy we like to teach them is that they should choose the largest number and put a box around it. We never want to decompose or write that number in expanded notation. So we just bring it down and write 42. The second number, or the smaller number, is the number that we need to decompose or write in expanded notation. And we know that this represents 2 10s, which is 20, and a 3. And so what we do now is we take 42 plus 20, and we have taught the kids how to add on a hundreds chart. And so they know that by coming over here to their hundreds chart, by adding 20, they go 10, 20, and that equals 62. So now I teach them to cross these numbers out because we have added 20. The only thing left now to add is 3. So I take 62 plus 3. And students know that 2 plus 3 is 5. So once they know these basic addition facts to 10, they say, well, if I know 2 plus 3 is 5, I know that 62 plus 3 is 65. And we always tell kids that good mathematicians circle their answer so that we know what their answer is. And we cross that out. After students have mastered 2-digit addition, we will now teach them how to do 3-digit addition. And this becomes, once they are solid with 2-digit, the 3-digit becomes very easy for them because they understand the procedure. So again, when we're adding, we tell them to box the biggest number. We're going to glue that number together. We're not going to decompose that. And I just write it again. The second number is the number that I do decompose or I write in expanded notation. And so I just underneath here, just so that I don't get confused as to what I've added, I put 120 and 8. And they can put little addition signs in there if they want to. So the first thing we do is we add 100. And because kids are familiar with their place value blocks, they know that when we have 251, by just adding another number, the only number that's going to change is the number in the hundreds. So we will have 351. And again, so that I don't get confused and lost, I cross off these numbers that I've used. And I know now all I have to do is add 20. So I bring this number down, 351 plus 20. And now kids know that I am just talking about the 10 rods. And so the number that's going to change is the number in the tens position, which is the 50. So 351 plus 20 is 371. I cross off this 20 so that I know that I've already used it. I bring this number down, 371 plus 8. Again, if kids are fluent with their facts from 0 to 20, then we know that 1 plus 8 is 9. So just because we add the 300s and the 70 on there, 371 plus 8, if I know that 1 plus 8 is 9, I also know 371 plus 8 is 379. I've used my 8 and I circle my answer, and that's how I do it. Another tool we use is a number line, and students are very familiar with a hundreds chart. In fact, we've been known to cut this hundreds chart apart and tape it together to show kids that this is just a continuum. It's just a different way to show it. And so a number line is much like a hundreds chart. Once they see that a number line is a tool that we can use to add numbers. So with this particular problem, it's 23 plus 45, and we teach them the most efficient thing to do is to choose the larger number to start with. So again, I'm going to put a box around the largest number. That's where I'm going to start on the number line. We spend a lot of time looking at number lines and estimating where numbers fall on a number line. So if we were starting at 61, we would teach kids that their line should be closer to 60 than 70. In this instance, my problem is 23 plus 45. 45 is halfway between 40 and 50. And so that's where I'm going to start. And I might just circle that so I know that that is my starting place. Then we can decompose this into 20 and 3. Some kids need to even break it apart farther and jump by tens, and that's okay too. So we jump our tens, 10, 20, and I put plus 10 here, and I can put plus 10 here, and I can signify where I landed at 65. So I've jumped 2 tens. Now all I have to do is jump 3 more, and we might go 66, 67, 68, and 68. And you can do plus 1, or you could just put plus 3, and we end up at 68. Sometimes kids don't need to have all those benchmark numbers on a number line. Sometimes they can do the same thing with an open number line. And this strategy is for kids who've pretty well mastered the other strategies. And this is just a quicker way for them to do it. So again, they see the bigger number and they glue that together. And what they do is they decompose the second number or write it in place value. So we have 100 plus 40 plus 1. And what they do is they just jump one big jump. And that signifies a jump of 100. And that takes them to 446. Then they don't have to do it in hundreds, tens, and ones. If they would like to add the 1 next, that's fine. 447. And then the last thing they can do is add plus 40. And again, if they wanted to break that 40 apart and add 10, 10, 10, and 10, they can. But if they already know that 447 plus 4 is 487, they can jump right to the answer. And again, we want them to circle the answer to show what the answer is. So 487. So far, all the problems that we've done do not involve regrouping. And so I'm going to show you another way that you can add. And so again, we look at both these numbers and we start with the largest number. So 35, and then I'm going to decompose this number into 20 and 9. And so 35 and 20 is 55. And so 55 plus 9. What we teach kids to do is to decompose that second number. And so we are going to ask them, what is the 10 that comes right after 55? And that 10 is 60. So what is it going to take for me to add 55 plus 5 will get me to 60. And this is called bridging. We want kids to bridge to the nearest 10. So I had 9, I took away 5, and now I have 4 left. That way kids can see 60 plus 4 more equals 64. And that's my answer. So we bridge to the nearest 10 and we split up that number so that we can make it manageable and we can work with numbers that way. All right. As kids get really good with breaking apart numbers and manipulating numbers, they're going to be breaking apart numbers that make sense to them, and that's okay. We just want them to be able to show their work, because as they go on, right now many of our students are able to add these numbers in their head without showing their work, and that's really good. But when they get into algebra and harder math problems in just a few years, they have to be able to show their work. The other thing is they're not going to be able to do it in their heads. So we're trying to give them tools that they can use and come up with the right number and work through a difficult problem. So hang with me for a minute while I work on this. I'm going to take 248 and I'm going to keep it together. And this number is the number that I'm going to start to decompose. So I have 100, I have 70, and I have 9. What I want to do first of all is use this 100. And I'm going to get to 348. Now, this is where I can start taking apart numbers, because I recognize that 348 is really close to 350. How close is it? 2. So I want to take 2 away from here. And if I decompose that number into 2 and 7, I want to use that. 348 plus 2 gets me to 350. Now, I'm at 350. I know that if I add 50 to that, I'm going to be at 400. So I'm going to take this number apart, and if I have 70 and I use 50 of that, I will have 20 left. So I'll do 350 plus 50, and now I am at 400. Well, most of the kids who will be decomposing these numbers and moving them around, they can quickly see that 20 and 7 is 27. We can put them back together now, and we can add 400 plus 27 is 427. The most important thing that you need to know here is that kids, it's okay to take numbers apart and put them back together as long as they get the right answer and they've shown how they have worked the problem. We always start out by teaching children addition, and subtraction is a little bit harder concept for kids to work. So we start back with the place value blocks, just like we did with addition. And that is why we always start with the larger number, because when we get to subtraction, if they're used to starting with the larger number in addition, this transition isn't as hard. So we always keep this number glued together, as we say, and I have drawn this out. There's 10, 20, 30, 40, 50, 51, 52, 53, 54. Yes, I indeed drew 54 blocks. Now all I have to do is take away 2, because there's a 2 in the tens place, so that means I'm going to get rid of 2 tens, and I also need to get rid of 2 ones. Now all I have to do is count what is left. 10, 20, 30. 1, 2. Add those two numbers together, and my answer is 32. So 54 minus 22 is 32. We're going to do the same problem that we did in the last video, but this time I'm going to use place value. So again, we're going to box the bigger number, we're going to glue it together, and we're never going to take that apart. Then I'm going to write 54, and now I decompose the second number into 20 plus 2. Sometimes we know that 20 plus 2 is 22, but for kids doing subtraction, we might want to say 54 minus 20 and then minus 2. So we can add that subtraction in there if we want to. So 54 minus 20 is 34. I've taken away 20. Now I need to subtract 2. 34 minus 2 equals 32. And I circle my answer. Subtraction can also be thought of as a difference. And so we teach kids that anytime, especially in word problems, when they say, what is the difference between two numbers, that means it's a subtraction problem. It's also true of a comparison problem. So I'm going to take the same problem, and this time I'm going to use a count-on strategy because addition was always easier for me, and so subtraction always got me lost. So I'm going to show you how to do a count-on, and then I'm going to show you how to do a count-back strategy. So I'm going to draw a number line, and on that number line I'm going to start it at 22, and then I'm going to go ahead and put in my benchmark numbers. Benchmark numbers are numbers that are multiples of 10. So after 22 would be 30, then I would have 40, and then I would have 50. Now I need to only go to 54, so I'll put 54 right there. I'm going to take another color, and what I'm going to do is I'm going to say, well, I know that to get from 22 to 30, that is an 8, a jump of 8. It's really easy then to put a jump of 10, another jump of 10, and then I want to get a jump of 4. Do you see how I'm adding to get to my answer? I'm comparing this number with this number. I always say to the kids, well, that's really nice, but where's the answer? And then they are to respond in the jumps. So 10 plus 10 is 20, plus 8 is 28, and then 28 plus 4 is 32. So we're wanting them to show their answer, so I make them go back and show it. The answer is in their jumps. And I can put little addition signs in here and an arrow up here and circle my answer. So the answer's in the jumps. Now, if you don't like to add, you could do the same thing. And this time, I'll start at 22, and I will put my benchmark numbers in. And you could subtract. You could go back, and your answer will still be in the jumps, but you will still get the same answer. So some kids like to jump back, some kids like to count on. Now we're going to subtract two 3-digit numbers, and we want to show kids the most efficient way to do it. Some kids might want to do it like the last time we talked about, putting both numbers on a number line. But for this instance, that's not the most efficient way. We're going to have way too many jumps, and when you have way too many jumps, you might get confused and get lost. So on this one, we're going to make a number line, and on my number line, I'm going to put 534. And I'm going to come down here and I'm going to put my benchmark number, which in this case would be 500. And if kids wanted to, they could put the tens in there if they wanted to. Then I'm going to come down here and put 400. And so I can kind of start working on this. I can say, well, I'm going to jump, box this, sorry, 120 and 7, and I'm going to put my subtraction marks in there, 434. Now, I need to take away 20, so here I can take away 424, 414, and then I know a double. I know that 7 plus 7 is 14, and I see that I have 414, and I have to take away 7. So my answer is 407. Second graders sometimes, as well as their teachers, don't always adjust right. And so if I can see the jumps, I need to mark these 100, 10, minus 10, minus 7. I can see their thinking that's involved, and even though we kind of got really close together, I came down here and drew the answer. So